talk about power. Power is a fascinating subject. It is the rate at which work is done. Now, you remember from your math classes, rate means it's going to be per time. So power is the rate at which work is done or work is transferred, or, excuse me, at which energy is transformed. Now, for units, we're going to use the watts. We could use a joule per second, but physicists are lazy. We want to make things as simple as possible, so we're going to use this capital W for power. Now, I know this is a little confusing because we're already using capital W for work. You just have to keep straight when it's standing for work and when it's standing for watts. Now, the English use the system of horsepower, where 1 horsepower is 746 watts. Now, horsepower is literally that. It was literally how much work 1 horse could do in a given time, how many tree stumps they could pull up. It's an interesting study to see where this actual unit came from. So, engines use a power rating, and it is a measure of the chemical or electrical energy that we transform into mechanical energy per unit time. So once again, we see it's this energy transfer per time, or the work your car engine does per time. These are equivalent statements. Now, we use light bulbs all the time. Light bulbs are rated in watts. This is their power rating. So a 60-watt bulb, okay, means it converts 60 joules every second. Heaters change electrical energy into thermal energy. That's why they're nice and warm. While light bulbs change electrical energy into light. So you see, this is the energy transfer per time. So it's electrical to light, electrical to thermal. Now, what's the difference in work and power? They're related. Power is work divided by time. Now, suppose you climb stairs. Just imagine you're going up a set of stairs. We're going to pretend like those are like normal stairs here. If you walk, you can do it really for a very, very long time. But it's going to take you more time. If you run, it's going to take you more power, and you're only going to be able to run up the stairs for less time. You're limited by your power. Now, car engines do work. They have to overcome friction. They have to climb hills. They have to accelerate. Your car is limited by the rate at which it can do work, which is why we rate cars in horsepower. So, the power of your car, the horsepower, is a measure of the work it can do per unit time. So, if you think about it, you go and you get on the interstate, you'll see those little tiny cars with large horsepowers are accelerating at a much faster rate and getting a lot more tickets than the great big older vehicles with less horsepower. So cars with lower horsepower ratings can't accelerate as fast as cars with very high horsepower ratings. They can't convert the gasoline into work to overcome friction as fast. Now, here are formulas. I know work is FD. Now, power is work divided by time. Now, I'm going to do a conversion here. You remember, work is FD divided by T. Now, I'm going to come down here and I'm going to rewrite this. Do you remember what we called distance over time back 6 units ago? Didn't we call this the velocity? So if I am moving, say, something with a constant force and a constant velocity, then the power um, I'm exerting is that force times that velocity. So here's another way you can write power. It's either the work divided by the time, or it's the constant force times the constant speed. And constant is the key word here. I need constant force and constant speed.